Take a look at almost any modern car, whether it's a compact hatchback, a family SUV, or a high-performance sports car, and you'll notice something they all have in common. Their windshields aren't standing straight up. Instead, they're tilted backward at an angle. It's such a familiar design that most of us never stop to wonder why. Was it simply a styling choice, or does that slanted piece of glass actually serve an important purpose? So, why are car windshields slanted? Today we're exploring the fascinating engineering behind one of the most overlooked parts of every automobile right here on History of Simple Things. The biggest reason car windshields are slanted is to reduce aerodynamic drag. As a vehicle moves forward, it constantly pushes through the air. If the windshield were completely vertical, it would act almost like a wall, forcing the air to slam directly into it. This creates a large area of high pressure in front of the car while leaving turbulent, swirling air behind it. That turbulence increases drag, making the engine work harder to maintain speed. By slanting the windshield backward, engineers allow the airflow to travel more smoothly over the roof instead of abruptly crashing into the front of the vehicle. Less drag means the car requires less energy to move, which improves fuel economy or extends the driving range of electric vehicles. While the windshield isn't the only aerodynamic feature, it plays a surprisingly important role. Combined with rounded body panels and carefully shaped mirrors, the angled windshield helps modern cars cut through the air far more efficiently than older vehicles with upright glass. A slanted windshield also improves what drivers can see. At first glance, a vertical windshield might seem like it would provide a more direct view, but the opposite is often true. The angled glass reduces many types of reflections that can distract the driver, especially during sunrise, sunset, or nighttime driving. Light from the dashboard and other interior surfaces is less likely to bounce directly back into the driver's eyes because the glass redirects those reflections upward instead. The sloped design also allows the windshield to extend farther forward without making the vehicle significantly taller, increasing the driver's field of view. Rainwater tends to flow downward more effectively across angled glass, allowing windshield wipers to clear the surface more efficiently. Snow and debris are also less likely to remain stuck compared to a nearly vertical windshield. Together, these advantages help drivers maintain a clearer view of the road in a wide variety of weather and lighting conditions. Safety is another major reason windshields are slanted. Modern windshields are made from laminated safety glass, which consists of two layers of glass bonded together with a plastic interlayer. During a collision, the windshield helps support the roof and contributes to the structural strength of the passenger compartment. Its angled position allows crash forces to be distributed more effectively throughout the vehicle's frame rather than concentrating them in one spot. The windshield also serves as a critical backstop for passenger side airbags. When an airbag deploys, it often pushes against the windshield to inflate correctly toward the passenger. If the windshield were weaker or positioned differently, the airbag might not perform as intended. The slanted design can also help direct certain objects upward during impacts instead of allowing them to enter the cabin directly, although no windshield is designed to stop every object. Overall, its angle works together with modern vehicle structures to improve occupant protection. Anyone who has driven an older vehicle with boxy styling knows how loud wind can become at highway speeds. Much of that noise comes from turbulent airflow crashing against flat surfaces. A slanted windshield helps reduce this problem by guiding the air smoothly over the roof instead of creating strong pockets of turbulence around the front of the vehicle. Less turbulence means fewer pressure fluctuations, resulting in a quieter cabin. Engineers use wind tunnels and computer simulations to study how air moves around every part of a car, including the windshield, mirrors, roofline, and windshield pillars. Even slight adjustments of a few degrees can noticeably reduce wind noise. This becomes especially important for electric vehicles because they produce very little engine noise, making aerodynamic sounds much easier to hear. By carefully shaping the windshield and surrounding bodywork, manufacturers create a more comfortable driving experience, allowing passengers to enjoy conversations, music, or phone calls without constantly competing with rushing wind. Although slanted windshields offer many advantages, making them as steep as possible isn't always the best solution. Engineers must carefully balance several competing factors. A windshield that's too shallow can make the vehicle longer and reduce headroom for passengers. It can also increase the amount of heat entering the cabin because of the larger glass surface exposed to sunlight. Extremely sloped windshields may create optical distortion if not designed carefully, and replacement costs can increase because of their larger size and more complex shape. Designers also need to consider windshield wiper performance, roof strength, manufacturing costs, and the overall appearance of the vehicle. Sports cars often have more dramatically sloped windshields to maximize aerodynamic performance, while trucks and SUVs usually use a more upright angle to improve interior space and visibility. Every vehicle represents a compromise between efficiency, comfort, practicality, safety, and styling, making the windshield angle one of many carefully engineered design decisions. The next time you get into a car, look at the windshield in front of you. Its slanted shape isn't just for style. It helps cars move more efficiently, stay quieter, improve visibility, support the roof in a crash, and work better with airbags. Like many everyday inventions, it looks simple because generations of engineering have refined it. Sometimes the smallest design choices make the biggest difference. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.